last video, we are discussing about the standard Ethernet. In standard Ethernet, we discussed about the characteristics of standard Ethernet, that is connectionless and unreliable service, frame format and frame length. These are the three characteristics of standard Ethernet. We also discussed addressing. There are three types of addressing: unicast, multicast and broadcast. Okay. Today we are going to discuss some more topics of standard Ethernet, that is access methods of standard Ethernet and efficiency of standard Ethernet. Okay. Next implementation of standard Ethernet, and the last one is change in the standard Ethernet. Four concepts we are going to explain in this video. Okay. First we discuss characteristics and addressing in last video. In this video I am starting from access modes of standard Ethernet. Okay. Standard Ethernet use one persistent CSMA bar CD. We know that we discussed three types of persistent: one persistent, non-persistent and P-persistent of CSMA bar CD. But in this standard Ethernet, we are going to use only one persistence of CSMA bar CD. Okay. CSMA means carrier sense multiple axis bar collision detection. Okay. Under access method, time slot. What is meant by time slot? Time slot is equal to round trip time plus time required to send the gem of a sequence. Gem means cluster, means set of sequences. Okay. What is meant by round trip time? RTT means time required for the frame travel from one end of the maximum length of network to another end. Nothing but it is the time required for the frame to travel from one end to another maximum length of network to another end. That is round trip time. Slot time is defined in bits, means we are going to define the time slots in the form of bits. Okay. Time slot is a time required for the station to send 512 bits. Means time slot is a time required for the station to send 512 bit. Okay. Actual slot time depends on the data rate. We know that what is meant by data rate: number of bits sent per second. Okay. Next, times slot time and collision. Choice of a 12-bit slot time was not accidental, means it is not an accidental error, because we have to send 512 bits, means it is fixed. It is not an accidental. We have to send the 512 bits only. So it was chosen to allow the proper function of CSMA bar CD. Means why you are chosen this means to correct operation or function of the CSMA bar CD. Okay. Slot time and maximum network length means collision domain. Okay. There is a relationship between the time slot and the maximum length of the network, nothing but collision. There will be a relation between this time slot and maximum network length. This relationship is depend on the propagation speed of the signal in a particular domain. Means this relationship between the time slot and the maximum network length depends on the propagation speed of the signal in the particular media. Means it is going to depend on the propagation speed of the signal in the particular medium. Medium is nothing but the link. Okay, in most transmission media, the signal propagate at the 2 into 10 to the power of 8 per second, means 1/3 of the rate for the propagation in air. Okay, this value is 1/3 of the rate for the propagation in the air. For traditional Ethernet, we calculate maximum length. There is one formula to calculate the maximum length. Okay, what is maximum length is equal to propagation speed into slot time divided by 2. Okay, we know that this is the propagation speed and time slot divided by 2. Time slot is given by 51.2 into 10 to the power minus 6 divided by 2. We are going to get 5120 meters. Okay, this is the maximum length of the media. You are going to calculate the maximum length. Okay, the maximum length is 5120 meters. Okay, this is the end of the access mode of the standard Ethernet. Next, we will move on to the efficiency of standard Ethernet. Efficiency is depend on the ratio of the time used by the station to send the data to the time the medium is occupied by this station. Okay, efficiency is defined as the ratio of the time used by the station to send the data to the time the media is occupied by this station. That is efficiency. Next, partial efficiency is given by efficiency is equal to 1 divided by 1 plus 6.4 into A. What is this A? A is nothing but number of frame that can fit on the media. Means number of frame that can be fit on the media. Means this is the media. Okay, this is station, this is station, this is media. Media is nothing but the joining of two station, and we are going to pass the information to this media. That is nothing but our link. Number of frames that can be fit in the media, means number of frame fit in this media, we are going to call it as A. A is equal to propagation delay divided by transmission delay. To calculate A, there is a formula: propagation delay and transmission delay. Here delay is nothing but waiting. Okay, the value of parameters decreases, efficiency increases. Means the value of this A parameter decreases, efficiency increases. Okay, length means if delay is low, means obviously efficiency will be high. That is only they are telling value of parameter decreases, efficiency increases. Next, length of the media is shorter or frame is larger, efficiency increases. In that type also the efficiency going to increase. Next, in the ideal case A is equal to 0. Suppose this A is equal to 0 means the efficiency is 1. Obviously, you can see that 6.4 into 0 means we are going to get 0 only. 0 plus 1, 1. 1 divided by 1, efficiency is equal to 1 only. They are telling that in the ideal case, A is equal to 0. A is equal to 0 means 6.4 into 0, we are going to get 0. 0 plus 1, 1 only. 1 divided by 1, efficiency is 1. That's it. Okay. Next, implementation of standard Ethernet. Standard Ethernet defines several physical layer implementation. Means here standard Ethernet defines the several physical layer implementation. Means this standard Ethernet going to define the several physical layer implementation. Okay, this is done by using encoding and decoding. What is encoding, decoding? We know that. Okay, in all standard implementation use digital signaling base band at the 10 Mbps. We know that standard Ethernet will use the bit rate or data rate is 10 Mbps. Okay, so all the standard implementation use digital signaling, nothing but base band at the data rate 10 Mbps. We know that at the sender data are converted into digital signal using the master scheme. At the receiver, the received signal is interpreted as a transistor and decoded into data. Means they are telling that we are going to use the transistor coding. Okay, for encoding and decoding. You can see that here also transistor encoding is used, transistor decoder is used. What this transistor encoder will do at the sender, this is sender part, data are converted into digital signals. Okay, means the data will be converted into digital signals using transistor scheme. Using this transistor encoder, we are going to convert the data into digital signal. Okay, at the sender, what will happen in the receiver? At the receiver, received signal is interpreted as a transistor and decoded into data. Means here transistor decoder will do that. The digital data will be converted into normal data. Okay, here in encoder will convert data into digital signal. Decoder will convert digital signals into normal data. Okay, next it can be implemented in 4 ways: 10 base 5, 10 base 2, 10 base T, 10 base F. Here 10 base 5 is nothing but thick Ethernet. 10 base 2 is nothing but thin Ethernet. Next 10 base T is nothing but twisted Ethernet. Next 10 base F is nothing but fiber Ethernet. Here we are going to use the media. What are the media we are going to use in each of this implementation? We are going to use 10 base 5. In 10 base 5 we are going to use thick coaxial cable. Medium length means what is the length of this medium is 500 meters. Encoding we are going to use transistor. We know what is meant by transistor. It is going to convert data into digital form. Next 10 base 2 thin axial cable we are going to use. The meter is 185 meters. Here also encoding transistor only. Next 10 base T. Here we are going to use two pairs of twisted cable. Okay, the maximum length is 100 meters. Next, we are going to use encoding as main system. Next, 10 base F. Here we are going to use two fiber cables. Next, medium length is 2000 meters. Encoding is main system. We are going to discuss one by one. What is mean by 10 base 5, 10 base 2, 10 base T, 10 base F. Okay. Ten base F. Sorry, 10 base 5. This is thick Ethernet is another name of 10 base 5. Here we are going to use bus topology. We know that there is a 4 topology. One is bus topology, star topology, mesh topology, ring topology. Out of 4, here we are going to use bus topology. Okay. External transceiver is connected to thick coaxial cable. Means we can see that this is the bus topology. Means there is a one single line. All the devices are connected to that single wire. Okay, that is bus topology. Here you can see that the stations are connected to coaxial cable using the transceiver cable. Means using this transceiver cable, the station are connected into this thick coaxial cable. Okay. Next, we know that what is the maximum length of coaxial cable is 500 meters. Okay. Next, the coaxial next is transceiver is responsible for transmitting, receiving and detecting collision. What is the importance of this transceiver is nothing but transmitting, receiving and detecting data collision. Okay. Next, transceiver is connected to station via coaxial cable. We know that transceiver is connected to station on the coaxial cable. Cable provides the separate parts for sending and receiving. Means the coaxial cable provides the separate parts for sending and receiving. Collision can only happens in the coaxial cable. Means here where the collision will happen means only in the thick coaxial cable the collision will happen. Okay. Next, here what is meant by 10 base 5? 10 is nothing but 10 Mbps. 10 is data rate. Base is baseband. Means it is our data is going to convert it into digital. We know that is base here. 5 is nothing but maximum length of the cable here. Here maximum length is 500. Okay. Suppose if given coaxial cable is not 500 meters, then there will be a excessive duration of the signals. Means if the length is more than 500 means then there will be a excessive degradation of signal. Means there will be a signal will be low. Okay. If the maximum length is extruded 500, okay, means they are telling us suppose we want to increase the length of the coaxial cable means we are going to divide the length into 500 meter 500 meter segment, okay, and connected using repeaters. Means suppose the length we want more than 500, means we are going to divide it into that cable into parts. Each part should be 500 meters 500 meters, okay. To connect this 500 meter cable, we are using repeaters, okay. This is 10 base 5, nothing but thick Ethernet, okay. Next one is 10 base 2 thin Ethernet. Means we are going to use thin coaxial cable here. Here we are also using same bus topology. Here also bus topology. Here also bus topology we are using. Cable is much thinner, more flexible than 10 base 5, nothing but thick coaxial cable. Means we know that here we are using thin, here we are using thick coaxial cable. We know that what is meant by thin means it is going to thinner than this thick coaxial cable, more flexible. Flexible means we can bend easily, okay. Flexible means cable can be bent to pass the very close to the station. We know that we can bend that coaxial cable. Transceiver is part of the network interface card installed inside the station. Means in previous example we are using the transistor here, okay, to connect the station on this coaxial cable. But in this base 10 base 2 we are using the transceiver inside the station only. Means transceiver will be present inside this stations only. Means here transceiver is the part of the NIC. NIC is nothing but network interface card, okay. Here 10 base 2, here 10 represent the data rate, nothing but 10 Mbps. Base is nothing but base band, means digital, means data will be converted into digital format, okay. It 2 represent the length of the coaxial cable, nothing but 185 meters. Maximum length of this coaxial cable is 185 meters, okay. Collision can happen in the coaxial cable. Means the collision can happen in only in the coaxial cable, okay. There is a advantages of thin Ethernet over a thick Ethernet. What are the advantages? You can see here, coaxial cable is less expensive than the thick coaxial cable. Obviously this thin coaxial cable is less expensive than the thick Ethernet, thick coaxial. Next, T connection are much cheaper than the taps. You can see that these are the T-shaped connector used to connect this station, okay. This is less expensive than the taps, okay. Installation is simpler because the thin coaxial cable is very flexible, okay. Implementation is very, because you can bend easily. Next, what is the disadvantage of this thin Ethernet? Length of each segment cannot extend at 855 meter due to the high attenuation in the cable. Means there should be only 85 meters, should not be more than that 85 meters cable, okay. Next we are move on to 10 base T, means twisted pair Ethernet. What is twisted pair Ethernet? We are going to see here we are going to use bus topology. Okay, bus topology means we are going to use one single node. We are going to connect all the station to that single node. This node is called as hub. Okay, you can see that this hub is used to connect all the station, means this is central. All the station will connect to this hub. Okay, to connect station to this hub, we are going to use two pairs of twisted cable. Okay, two pairs of twisted cable that create two parts between the station and hub. Here having two pairs of twisted cable means there will be two paths will be created, one for sending, another one for receiving. Collision happens in only hub, means collision can happen in only hub part. Okay, minimum length of this twisted pair is 100 meters. Okay, 100 meters. Next one is here 10 is data rate, base is baseband, T is our twisted pair Ethernet. The maximum length is 100 meter. Okay, next 10 base F, nothing but fiber Ethernet. Here also same, we are also using star topology. Here we are using star topology, not bus topology. In 10 base T also we are using star topology. In bus also we are using the 10 base F. In this also we are using this same star topology. What star topology is nothing but the single hub is used to connect all the station. Okay, to connect station to hub we are using two fiber optical cable. Here also one for sending, one for receiving. Here maximum length of fiber optical cable is 2000 meters. Okay, this is the end of the implementation. Four types. First one is thick Ethernet. Here we are going to use bus topology. And 10 base to thin Ethernet. Here also we are going to use bus topology. Next 10 base T. Here we are going to use star topology, not bus topology. While explaining, I made a mistake that I told that it is a bus topology. It is a star topology. Star topology is nothing but one hub is used to connect all the stations. Next, here also same star topology is used. For first two we are using bus topology. In last two we are using star topology. Next one is change in the standard Ethernet. How we can make change in the standard Ethernet? There are three types for the changing this standard Ethernet we are going to discuss. Okay, change in standard Ethernet, it can be done in three types. One is using bridged Ethernet. Next one is using switched Ethernet. Next one is using full duplex Ethernet. Using these three types we can change the standard Ethernet. Okay, bridge Ethernet. Bridge have two effects on the Ethernet LAN. Using this bridge you can get two effective on the Ethernet LAN. What are the two effects? Nothing but they raise the bandwidth and they separate the collision domains. These are the two importance of this bridge Ethernet. Means it going to raise the bandwidth and separate the collision domain. Okay, raising the bandwidth. How we are going to raise the bandwidth? you can see that this is without bridge, means in one bus we are going to collect the 12 station. These are the station. Okay, in one bus we are connected 12 station. Okay, bandwidth, each work is independent. Okay, here we used this bridge, means we are going to divide this whole network into two parts. Okay, year to year 6 stations, year to year 6 stations. We know that what is the data rate is 10 Mbps, means here without bridge we are using 12 station in a one bus. This 12 bus should use the 10 Mbps data rate only, but when we use bridge means year 6 means there will be a only 6 station in each network, means there will be a separate network year to year. This is year to year one network, year to year one network. In network we should consider this bridge as also a one station, means each station will contain 7 and 7 station. Okay, means here this part also have the data rate 10 Mbps. This from this to this also having 10 Mbps. Out of 12 can share the 10 Mbps. To overcome this we use bridge. So 10 Mbps is divided into 7 station, means here 10 Mbps na 12 station use ಮಾಡಬೇಕಾಯಿತು, ಬಟ್ ಬ್ರಿಡ್ಜ್ ಯೂಸ್ ಮಾಡಿದಾಗ 10 Mbps na 7 station is going to divide the data rate. Okay, so this is the bandwidth will be increased because only 7 station using the our data rate. Okay, next separating collision domain. Next important of this bridge Ethernet is separating collision domain. Next, collision domain, you can see that this is domain using the without using the bridge, this is using the bridge. Here the without using the bridge there may be a more collision. Okay, because there will be a more station, but in bridge we are going to divide this 12 into more station into some groups of station is called domain. One domain we are divided. So here 12 station are divided into 4 domain, each domain containing the 3 station, means here the chances of collision is less. Here there are 12 station, here the collision may be more. So this bridge Ethernet will reduce the collision because we are going to divide large stations into small domain. In small domain less stations are connected, so collision is reduced. Next one is switched Ethernet. We know that the switch can contain the N ports. Okay, N ports, there will be a N domain stations are connect for each the port. When you want to send for this domain, means only that switch will be on, so there will be a collision is less, and there is a direct connection between the station and the switch. So the sending and receiving is very simple. Nothing but this is the extension of our bridge Ethernet. In bridge Ethernet also we are going to divide the large station into small station called domain. Here also you can see that these are the domains. Okay, and there is a direct connection between the domain station and domain containing the station and switch. Here also station and switch. So the bandwidth will be shared between this connected station and the switch directly. Okay, this is the switch Ethernet. What is switch Ethernet? The idea of bridge LAN can be extended to switch LAN, means this is the extended version of our bridge Ethernet. Last one is full duplex Ethernet. What is meant by full duplex? Nothing but at a time two stations can receive and send. That is full duplex. For example, full duplex is our mobile phones. Using mobile phone, you can talk also, you can listen to another person also. That is full duplex. Okay, the full duplex mode increase the capacity of each domain from 10 to 20 Mbps. Means you are going to using this full duplex Ethernet, data rate will be high. It will be change from 10 to 20 Mbps. Yes, means data rate will be high using this full duplex Ethernet. Instead of using one link between station and the switch, and the configuration use two links. Okay, ಇಲ್ಲಿ one link use ಮಾಡೋದ್ರ ಬದಲು we are going to use two links, one to transmit, one to receive. Means we are going to use two links instead of one link. Two links use ಮಾಡಿದ್ದೀವಿ ಅಂದರೆ one link for receiving, one link for sending. Okay, next, no need for CSMA bar CD. Means this no need for this CSMA bar CD. Means this access method is not needed in full duplex mode. Why is not needed? Means you can see that in full switch Ethernet there is no need for CSMA bar CD method. Each station is connected to switch via two separate links. Why this CSMA bar CD is not needed? Means between station and the switch we are using two separate links. Each station or switch can send receive immediately without the warning about the collision, because we are using two links. Means one for receiving, one for sending. There is no for waiting. Means there is no need of or no happening of collision. Okay, the job of MAC layer becomes much easier. Okay, carrier sense and collision detection function of MAC sublayer can be turned off. Means carrier sense and collision detection function we are going through our MAC sublayer can be turned off. Means carrier sense ಮತ್ತು carrier detection function will be turned off in the MAC sublayer, because there is no collision happening, because immediate receiver and sending is happening in this full duplex mode. Next one is MAC control layer. To provide the flow and error control in full duplex, okay, switched Ethernet, a new sublayer called the MAC control is added between the LLC sublayer and MAC sublayer means to provide flow control and error control. Okay, in the full duplex switched Ethernet, we are going to use this MAC control between the LLC sublayer and the MAC sublayer. Okay, this is the end of the standard Ethernet. What is meant by standard Ethernet? Original Ethernet technology with data rate 10 Mbps. Okay, next video I am going to explain fast Ethernet. Okay, it is also nothing but original Ethernet technique with data rate 100 Mbps. Okay, we are going to discuss in next video. Thank you.